Question 4 and B. This is the part that I really wanted people to work on today. Sorry about fourth hour. And this also is just a good highlighting reason for why we want to use Euler form. Because if I just left W as is, so here's my W, and I want W squared. In order to do that, what I would have to do is take all of W and then square it, which would mean that I needed to distribute. And already this is getting pretty gross, right? Like I've still got to distribute the 2 to get this, and then I'm going to have to do this. I'm going to have to gather up all my i's, and it's like, blah, it's too much stuff. So because this is and we're only at squared, we haven't even gotten a cubed. For cubed, I need a whole extra one of these to deal with it. So instead, let's use Euler form. Remember, Euler form is if you have r cosine of theta plus I sine of theta, that's equal to r e to the I theta. So we could rewrite this pretty quickly and just say that W is equal to 2e to the I pi over 3. And then if we want to square it, it's much simpler. Because you're just going to set it up like this, where you have W squared, square this, and then you just need to distribute the 2. So you're going to end up with 2 squared e to the 2 pi over 3I, or 4e to the 2 pi over 3I. Boom. There's your squared. For your cubed, it's just going to be 8, or 2 cubed, and then e to the I pi. Works out quite nicely. Let me know if you have questions about that. And then, once you've got this, you can sketch this on your arcane diagrams. And again, just like we did with question 1, you guys could use this form, or if you wanted to, you could turn this back into Cartesian form. And so I'm going to show you both of those. So, using Euler form, if we want to graph just plain old, well, actually, let's start with this. W to the 0 is just 1. Because anything to the 0 is just 1. And keep in mind that this is going to be your real, and then this is going to be your imaginary axis. So W to the 0 is just going to be 1 unit that way, and then there's no imaginary component. W to the first power is just plain old W. So we're going to go in the pi over 3 direction, and it's going to be about 2 units long. So it's about like that, where this is approximately pi over 3, and this is going to be about 2 units. W squared is going to be 4 units in the 2 pi over 3 direction, so it's going to be about 4 units. So this is like 4 units long, and then this angle right here would be 2 pi over 3. And then the final one is going to be, oh, I guess they didn't even ask for a W cubed. Oh, it does. Just kidding. W cubed is going to be 8 units in this direction. And the reason it's flat like that is because the angle is just plain old pi. So you can use Euler form. No, this is not exactly perfect, and I haven't been super specific. I just kind of eyeballed it, but that's the gist of what you're going to be doing. If you wanted to use Cartesian form, then we need to convert all of these into complex numbers. And the way that you're going to do that is just like before, and I'm going to kind of zoom in here. This right here could be rewritten as 2 cosine of pi over 3 plus I sine of pi over 3. Then if you evaluate cosine of pi over 3 and sine of pi over 3, and again, I have a separate video for that if you want to do that, you will get cosine of pi over 3 is 1/2, sine of pi over 3 is root 3 over 2, and so if you distribute this out, you will just get plain old 2 times 1/2 is 1 plus root 3I. So that would be our W. So if we were going to go down and graph this, our W is going to function, and again, we've got our real, we've got our imaginary. And so in this case, I would want to go over 1 unit and up square root of 3 units. So over 1 unit here, and then up square root of 3. And hey, check it out. That jives pretty well with what we drew over here. And I skipped the first one just because we already know that one. Same way, if you guys convert, here 4 e to the 2 pi over 3 is going to end up being negative 2 root 3 plus 2i. So over here we'd go to negative 2 root 3 and about 2i, about here, and then you would get this vector, and hey, check it out, it's starting to look a lot like this picture. And then of course the last one is just going to be, because pi is 0, you just have negative 8, and so then you have a negative 8 here. Hopefully that helped out a little bit. Please let me know if you have any questions. If that didn't help, let me know how I can help you.